Now, I would like to welcome back our amazing speaker, Ovia Seshadri. Ovia is a respected research engineer at CoinDCX, specializing in proof of work blockchains with a PhD in computer science and engineering from IIT Delhi. As the Chennai chapter lead for TPG, Ovia is dedicated to fostering the growth of the blockchain community. With extensive expertise and a passion for innovation, Ovia contributes to shaping the future of blockchain technology. Welcome back, Ovia.
Thank you so much, Bhavya. It's nice to be back. How many participants do we have from last week?
So if you're there last week, sir,
All right, maybe you can conduct a poll and let me know.
yeah, I'm singing same.
Awesome. Okay, so I hope you guys remember what we discussed last week. But just to make sure, I have something for you guys. So that's 1 second. Yep. Okay, can you see my screen? Can you see my screen?
Yes.
Awesome. I'd like you guys to take out your phone and scan this QR code and join my little quiz. And I just want to know how many of you paid attention from last week. And if you get the questions wrong, you're not allowed in this bootcamp. I'm just kidding. just as a refresher, we'll do a small quiz. Shall I start the quiz? Just scan this QR code, guys. Once everyone is scanned, just drop in the chat box that you're ready to go. Then I can start the quiz. So, Bhavya, I'm going to share a link with you.
Yeah. Yeah, I can put it in the chat as well.
Yeah, you can like join this link also if you're going to join from your system. And then I will start the quiz. Okay. Yeah, or you can just go to slido.com and enter this code also. Cool. Okay, I'm going to start. Let's see who is joined. Just you can enter your name so I also know who's participating. So chance for me to get to know your names as well. Hi Dhruva, hi Avani, hi Boyun, Megan, Tejasvi, Pabla, Anne. Nice to see you guys. I can see that this Zoom has about 22 people. Excluding me and Bhavya, that'll be 20. So I'll wait for at least 20 names to come on the screen. So far, we have about 9. Is there anyone facing any difficulty in joining? Okay, Bhavya, should I start the quiz or should we wait for more people? There are 10. Okay, people are still joining.
Yeah, I think we can wait for a few minutes and then we can go ahead.
just 38 on my clock. So let's start at 40, 2 more minutes. You can scan this QR code or join in this link, or I've also put the link on the chat box. Listen, all right, people are still joining. Awesome. 15, 5 more to go. And 1 more minute. Meanwhile, if you have any questions for me from last sessions, you can also drop that in the chat box and I'll be happy to answer them. Okay. I think we're good to go. Shall we start, Bhavya?
Yeah, I think let's start.
Okay, cool. So I'm gonna give about I'll do that Tejasvi, but just before we'll just do this little quiz and then we'll recap on everything that was taught last session. Oh, we have one more person who's just joined. Okay. So I'm going to give about 30 seconds per question. And I have my clock on here with me. So that so it's exactly 30 seconds. Okay, so let's start. First question. So keep in mind there are multiple correct answers for this question. So you have to tick all the correct ones. 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So let's move on. We only have 3 more people yet to answer. Okay, 2 more. Okay, let's go on to the question. So most of you knew that authentication was the right answer. Some of you clicked non-repudiation, some of you clicked confidentiality, and some of you clicked message integrity. Let's see. The correct answer is digital signatures protect authentication, non-repudiation, and message integrity. Does not give message confidentiality. So let's see who got that right. Avani, congratulations. So this is the leaderboard. So let's go to the second question, you guys. There's only one correct answer for this question. Okay, 10 more seconds. Are you guys not able to answer because only 3 people have done so far? Okay, 4. Which of this is true about non-iterative consensus, guys? Okay, I'm going to stop now. Go on. Oh my God. Okay. So let's see what the right answer is. The right answer is non-iterative consensus can cater to dynamic networks. Everything else is true for iterative consensus. It's actually the opposite for non-iterative consensus. So Dhruva has gone up to the top now. Let's move on to the still a few more questions. So what is gas price? Eight people have answered. I'm happy that most people are answering correctly for this one. Awesome, 5 more. You can still join the quiz by scanning this code. Okay, I'm going to stop now. 4 more people, but it's okay. So many of you have answered, nobody thought it was units of gas allowed in a block. Okay, the correct answer is right. It's price in ether that the user is willing to pay for 1 unit of gas. I'm happy that at least half of you got this right. Vani is back at the top of the leaderboard. Next question, just 3 more questions. So Ethereum introduced what aspect of decentralization? There's only one correct answer here. Other questions too tough. We discussed all of it last week. Five more people to answer. One more people has a few more people have joined the quiz. I'm happy to see that. Awesome. Okay, let's move on. The correct answer is decentralized programmability. Decentralized storage was and decentralized consensus was already invented in Bitcoin. Ethereum brought about smart contracts, which gave decentralized programmability. That's the right answer. 60% of you got it, so it's good. Vani remains at the top of the board. Megan is in the second position. Dhruva is in the third. So let's see. What is a trie? Ooh. I can see what you guys are answering. I'm happy to see that again we have the majority for the right answer. 9 more people to participate in this question. All right. Okay, cool. Let's move on. Actually, the try is efficient for both read and write. If you can read to a particular place, then it's very easy to write at that place. So it's not so good for updates, but it's good for read and writes. I mean, yeah, even for updates, if you update is nothing but read, delete, and write again. So it's actually efficient for both. Last two questions. What types of accounts are there in Ethereum? So this is an easy one. I expect most of you to get it right. Awesome. So far, so good. Wow. This has been by far the best question that most of you have got right. Okay, so the answer is externally owned accounts and smart contract accounts. That's the right one. And 87% of you have got it right, which is great. Vani remains at the top, followed by, Megan is at the top now, then followed by Dhruva and Avani. Congratulations, guys. Last question. Come on. Again, this is multiple choice, many correct answers. Be careful. Last 10 seconds. Okay. We've had good performance for this question as well. Most of you have chosen value transfer, contract deployment, and contract invocation, and that is perfectly correct. So at the end of our quiz, we have Megan at the top, followed by Dhruva and Avani, Chan and Shub. Congratulations, guys. I'm happy that you guys were able to follow along last week. So that's it for the quiz. If you guys liked it, then we can do a similar quiz every week before we start. Okay, so coming back to Tejasvi's question, what did we cover last week? Let me just quickly share my screen again. Yep. All right, can you see my screen?
Yes, it's visible.
Awesome. Okay.
We can see the Slido screen.
Yeah, okay.
Yeah.
Okay, so this is what we did last week. We just went through what a blockchain was, what are the technologies that blockchain provides. We talked about P2P network, what cryptographic hashing is, how asymmetric key encryption works, how digital signatures work, and what consensus is. We look at a specific type of, we looked at the type of consensus, which is iterative and non-iterative. We saw that blockchain uses non-iterative consensus. We saw one particular type of non-iterative consensus called proof of stake system, which is basically where there are several validators, and the validator with the most stake in the system is given the chance to become a proposer who adds the next block on the blockchain. So we saw how that process works, how to become a validator, how a validator is picked into as a proposer. And then we went into how Ethereum works. We saw that Ethereum gives decentralized programmability. We saw what the native token in Ethereum is, which is ETH, and it has several denominations called WEI. We looked into the concept of gas. So we saw that there are several components to gas. There is a gas limit on the block, how many gas units a block can store. We saw that gas used is basically how much gas units is needed to execute a transaction. We saw gas price is how much money in ETH that a user is willing to pay for each unit of gas. And gas fees is basically the gas used into the gas price. Yeah, this is just concepts of gas. We saw how the Ethereum works and how gas is needed. Gas is basically needed to protect the resources of every validator who's verifying your transaction. You don't want any malicious code depleting the validator's resources. So that's why we have the concept of gas. We saw that there are two accounts in Ethereum: it's externally owned accounts and contract accounts. We saw that only externally owned accounts can invoke transactions. Only externally owned account can sign transactions. We saw that there are several properties in every account. So every account has an address and a nonce value, balance value, storage hash, and code hash. Okay. And we saw what tries are, and we know that every Ethereum validator stores the blockchain in tries in his local system. We saw what transactions are, what is the structure of a transaction, and we saw that there are three types of transactions that need gas and that need a signature. So they are the value transfer transaction, where you only send Ether from one account to another. All transactions originate from an externally owned account. So from an externally owned account, you can send some Ether to any other account, which is another externally owned account or another contract account. A contract deployment transactions, where you've written a smart contract and an externally owned account is used to deploy that smart contract onto the network. So it doesn't really have a recipient address. And then we saw that there's a contract write transaction, where you're basically invoking a function on a deployed smart contract from an externally owned account. So this is what we covered last week. Now we're in week 2. I did leave you with a thought of how everything fits in. So here we have we are writing smart contracts in a language called Solidity. We saw how the Ethereum blockchain works. Ethereum blockchain is a P2P network where it has a lot of validators. At some one epoch of time, one of these validators is chosen as the proposer, and he adds the next block onto the blockchain. We will enter this system. Parallelly, there are lots of transactions happening across the nodes in the blockchain. So there are many node providers like Infura, Alchemy, QuickNode, and we will be entering that blockchain. We will be seeing a view of the blockchain through these providers. And we're going to be using an externally owned account by MetaMask, and we're going to use that to interact with this blockchain. So that is the scope of this bootcamp. So this week, we will continue from last week. Last week, I wanted to set up our MetaMask and cover a blockchain explorer and talk about Remix. So today I'm going to continue with that. We'll look at what Remix is. We'll set up a MetaMask account, which is your externally owned account. And we'll look at a sample. We'll start looking at code this week. There's going to be a little bit of theory and a little bit of code. We'll look at a sample contract, and then we will start looking into constructs of the Solidity language, right? So before any questions? Bhavya, you let me know if there are any questions, right?
Yeah.
So there is, Tejasvi is asked, can we get a recording of the previous session? So yeah.
I'm sharing, yeah.
Okay. Cool. Awesome. So now we saw that there are three types of transactions that are actually written on the blockchain that will actually change the state of the blockchain that requires gas fees, right? One was the value transfer, another was the contract deployment, and another was the contract invocation. Now we're going to talk about two more transactions, which are not really transactions because they don't change the state of the blockchain. They are reading some data from the blockchain, but not writing into the blockchain. We just want a view of the blockchain to see its state. So these do not need they do not need any gas fees, right? So those are contract read transactions. That is, you want to read the state of a smart contract. So these will obviously have the nonce field. The gas price and gas limit is 0 because it doesn't take any non. So actually, these are not, even the nonce is not valid here. Sorry. So nonce is also 0. The gas price is also 0. Gas limit is also 0. There is an address of the contract to be interacted with because you're still invoking some read operation in the contract. So you need the address of the contract. And yes, so there is no transaction created for this. You're just reading the state of the contract, basically. And if you're invoking a read function in the contract, you can send the function signature also, which is basically the name of the function. Another transaction, which is not really a transaction, is the blockchain read. Like if you want to get the balance of a account, or if you just want to read the state of the try. So these elements can directly be retrieved by any of the node providers. So the node providers don't even have to talk to the other nodes to get this data. They have the local state stored. So it is basically like just querying a server for some information. So you're not really interacting with the blockchain at all. Okay, but if so here, if you notice that I've still written that a signature is required, because if it is a contract read, maybe there are there is a contract logic that says only the owner can read some information or something like that. So maybe for that you might need to prove that you are the one asking for this information. So let's not complicate things. So just know that three kinds of transactions that we spoke about needs gas fees and a signature. There are two other kinds of read transactions. One, you're reading from the contract, and other, you're just reading the blockchain data, which don't need any gas. So let's start with creating our externally owned account. So we're going to be using a wallet provider called MetaMask. So let me just, okay. So here I already have MetaMask stored here. And I have some Sapiola ETH, but let me just remove this for now. Okay, I'm going to remove from Chrome. Yeah, so it's going to ask me why I'm removing. Let's just close this window. Okay, I'd like you guys to follow along with me and let me know if you can't do it. So we're going to go to metamask.io. So in MetaMask, I would like you to use Chrome browser because MetaMask really works well in Chrome. In other browsers, you may face a glitch. So it's better to use Chrome. You can download for Chrome here as an extension. You can add to Chrome. MetaMask also works as a mobile application. If you want to do it that way, you can do that as well. You can download it from iOS and Play Store for Android. So now that it's been added to Chrome, I'm just going to close all the other browsers over here. So this is my MetaMask. Okay, what is a MetaMask? It is the externally owned account. And how is the externally owned account protected? We saw last week that it is protected by a private key, which has a corresponding public key, which will be your wallet address, account address on the network. So let's go ahead and create our public and private keys. So I'm going to agree to MetaMask, create new wallet. If you know your mnemonic phrases for your old wallet, you can also import an existing wallet. So I'm going to say create new. I suggest you read all this, but I'm just going to say I agree. Remember, it's going to ask for a password. So this password will only exist on the client side. So it is if you remove your browser extension, this password is no longer going to work. So this is not the actual, okay, what did I write? Okay. So this is, this password really doesn't matter, but yeah, it's good if you remember it. Create a new wallet. So now I suggest you watch this video in your free time, but it's just going to tell you how important your private key is. And if you lose your private key, you will lose access to your account. So we can also call this MetaMask, just an externally owned account, a self-custody account, because you have the custody of the private key. Nobody else is keeping it safe for you. So I'm just going to say secure my wallet, and it's going to show me a set of words that are used to create the private key. The private key will be a mix of values, so which is very difficult to remember. So they're giving you a set of 12 words which are used to create that complex private key. So you have to remember the words in the same order. So if I say reveal my secret key, I don't care so much about revealing it to you guys because I'm not going to store any real money in this account. But ideally, you should keep these keys safe, and you should not probably write it down somewhere. So I've just copied it over here. I'm going to write it down in 1 second. Right. Okay, so I'm just going to copy my keys over here, and I'm not able to copy them. So let me just do this. Copy, paste. Yeah. So these are the keys, recycle face. So I'm just going to keep it safely in a notepad for now. And I'm going to click next. Make sure you copy your keys too. Please let me know if you're not able to follow, and let me know if you're following along as well. So now it's confirming whether we remember the keys or not, because it doesn't want us to lose custody of the assets in our wallet. So I'm going to, what was the third one? So I have recycle face and rare. So I'm going to type rare over here. My fourth word was Ali. And the eighth word was member. So these are my 12 words. It's asking me to confirm. I'm going to confirm it. And I'm all set. So installation is complete and it's done. Awesome. Okay. So now I have my MetaMask wallet all set up. It was just as simple as that. So an easier way to access this wallet is as a browser extension plugin like this. You can see a jigsaw puzzle icon on the top of your browser. If you just click that, you can see MetaMask over here. I'm just going to pin it so that it is directly visible for me in one click on the top of my browser. So I can just close this. I can close all of this and this. Okay, just gonna open a new one. So this is my MetaMask wallet. As you can see, a wallet address has been created. So I can see my account. I have one account here, and this is my address. So let me just paste it out for you guys so you can see what my address looks like. So this is my wallet address, a hexadecimal string, which was created using my public key of the corresponding private key that I have for my wallet. So this is going to be my entry point or my identity on the blockchain. Anything I do on the blockchain will be associated to this address. Okay, we can also check that. So so one second, let me just share my screen again. Yeah, so we said that any blockchain network needs an entry point or somebody who has maintained a local copy to see. So one of these providers is called Etherscan. Okay, so Etherscan is a block explorer. You'll find that most of the blockchains out there will have a good block explorer for you to just see the local state of the blockchain from any one of the validator nodes. And Etherscan is a service provider like that. So this is how the Etherscan page looks. And I have already logged in. I mean, you don't have to log in to access this. You'll be able to read the state of the blockchain even otherwise. So now let's just see if my wallet has actually been created. I'm going to paste my address over here, the wallet address that I just found in MetaMask, that I just got in MetaMask, and I'm going to search for it. And if you can see that it knows that it is a wallet address, and it knows that it doesn't have any balance, and there are no transactions that have happened in this wallet so far. I have not done anything. But yeah, so it recognizes that this is an address on the blockchain. This is because MetaMask also has nodes, and when you create an address with MetaMask, it has kind of maybe informed all its peers that this address exists on the network. Okay, so now let's look a little bit into detail on how Etherscan works. So Etherscan is, as I said, is the block explorer. You can search for anything on Etherscan, any account, be it an externally owned account or a contract account. You can search for transactions that have happened. Every transaction that I said, the three types of transaction, which is the value transfer, contract deployment, and contract invocation. Each transaction will also have a transaction ID, which is called the transaction hash. You can search for that. You can search for a block hash also. Token is just a smart contract. We will come to it maybe in the next week's session. And domain name is a very specific kind of thing. It's like if you're familiar with DNS lookup, that is domain name service. So any URL, any IPv4, IPv6 address can be translated into a human readable form. So you can type out, like facebook.com or google.com, and your service provider will know exactly which IP address to go to and the routes. So similarly, instead of giving a very complex alphanumeric string, which is the address of your account, you can just convert it to something simpler. So for example, you can do, I think Vitalik has let's try Vitalik Buterin has an ETH, Vitalik.eth. So Vitalik Buterin, as we said, is the founder of Ethereum. Yeah, he has ETH. Let's see how much money he has. Okay. Awesome. So he's done a lot of transactions. So basically you can stalk people, if you have their addresses. I have a ENS name as well. So is everyone with me so far? Have you all created your wallet address? Okay. So now Etherscan has a lot of tabs over here. We are at the home screen now. Under blockchains, you can see, and currently we're looking at the Ethereum mainnet blockchain. So you can see all the transactions that have happened. Pending transactions means transactions that have been broadcasted but not yet included in a block. Then yeah, so you can explore so blocks, folk blocks, uncle. So this is not needed, we're not going to explain this, but if you still have a doubt, you can like ping me and I can answer this outside the course. And tokens, top tokens, if you're into trading. Yeah, Bhavya, you have a question? Is there a question?
Yeah, so Makai is asking if you could show where we can find the public address again.
In MetaMask? Yeah, so you
Yes.
can put this MetaMask. You can see that this is your account one. Under that is your wallet address. You can just copy that and you can search for it here if you like. But basically, this is how people will identify you on Ethereum. So it's a good idea to know that address. Any other questions?
No, that's all for now.
Let's move on. So tokens and NFTs, we will look at in detail when we talk about ERC20 and ERC721. But I do want to bring your attention to the developer properties that Etherscan provides. It has a lot of APIs. So if you can go to API documentation, if you have already signed up on, if you have an account in Etherscan, you just log in and sign up. It'll give you an API key, or you can create your own API key. And using that API key, you can basically read data of the blockchain using Etherscan. So if you look at accounts, maybe, so it exposes a lot of API endpoints, and you can basically read the data from any dApp that you're building using your API key token. So let's say that get Ether balance for a single address. So this is one of the API endpoints that Etherscan exposes for account information. So these are, you can just go through all the different stuff that it exposes. I'm just going to use one here. I'll just go through this. So if I query this, basically, let me open up Postman. Yep. So I have Postman over here. Let me look at my collection. I'm just creating a new request. So whatever I pasted in Etherscan, I'm just going to paste it over here. Let's see. Okay. So now it has a bunch of stuff. So I'm going to replace it with my Ethereum address, which is this one. Let's go back here. So my address is, I'm going to paste it here. FDA6. I'm just going to remember the last 3 digits was 0E7. And this is my API key, which I can get from my account. So there's after you sign in, there is a thing called API keys. Again, you should not be showing this to anybody, but I just created an API key for now, but it is highly rate limited. So I don't mind showing you this, guys, because I'll probably delete it right after this session. But if you're using something, if you're developing a dApp and using it for production, you should not be revealing your API keys. So after I copy that API key, I'm going to paste it over here, which I've already done. And if I click send, Yep, I have a result which is 0, which is basically what this API does. I have been using this API, right? Like what? I just invoke this one, which is to get the ether balance for a single address, and for my address, the ether balance is 0. So that's how you would use your API keys for Etherscan. Some other really cool features in Etherscan is the verification and signature parts. So let's say that you want to verify something to somebody. You've already created a public key, private key pair in MetaMask. You can use that public key, private key pair off chain to verify any message, because everybody will believe that the private key is only yours. You can use your MetaMask public key, private key as a the Ethereum public key, private key as a certification authority. Basically, you can sign any message, and yeah, Etherscan will verify it for you. So let us do that. So I'm going to connect my Etherscan with MetaMask over here. So it's asking, MetaMask is asking me if I can connect to this website. So I'm going to say yes, connect. So connection is done. So as you can see, it has already retrieved my address from MetaMask. And I know it is my address because it ends in 0E7. So I'm going to write a message here saying Solidity is fun. This is my message. And if I sign this message, I'm just going to copy this. Okay, I know this is the message. If I sign it, it's asking MetaMask to sign, because only MetaMask has my private key and only MetaMask will be able to sign it. So the message, Solidity Fund, do you want to sign? Yes, I want to sign this message. It's not going on the blockchain. We're just using this keys that we've already generated off chain to sign any message. So it has used this address, this private key basically. So people can verify the message using this address. And we've signed the message Solidity is fun using my private key. And this is the signature hash. So using the signature hash and the public key, we should be able to check whether I have actually signed this message or not. So if I copy the signature hash, I can publish it if I like, but I'm just going to close it for now. I can also verify the signature. So now if I can, let's say, I want to say this is Ovia. And if I use the same signature hash, which I just copied, right? If I, and I give the same address, which is, what is my address? Yeah, 0E7. I give the same address and this message. This, if I continue, the signature verification has failed because this message is incorrect. So now if I give Solidity is fun and continue, the message should succeed because, yeah, it's verified. The same message with the with this address is matching, the algorithm matches to the hash that is produced over here. So if let's say if we change the hash a little bit, right? So if I change the last B to C, oh, I'm not allowed to do that. Okay. Okay, but you get the idea, right? So we saw how asymmetric key encryption and digital signatures work last week. So this is a cool way to try that out. So that's pretty much it on Etherscan. We'll be using a lot of Etherscan later on, but this is what I wanted to show you. But now let's get some money into our ETH. I mean, into our MetaMask. Of course, we don't want to play around with ETH because ETH costs a lot of money. So what MetaMask or what Ethereum Foundation has done is they have created a replica of the Ethereum blockchain for us, just with only fake money, so that we can play around with it and we can experiment, we can test our code, and that is called a testnet. So now let us add a testnet. So there is an option if you open your MetaMask here, and there is an option at the top saying this is Ethereum mainnet, and there's a drop down here. Click that, and there is an option that says show or hide test networks. We're going to click that, and we're going to enable show test networks. Close this, and you should see a lot of test networks here, apart from the Ethereum main network. So now we're going to use something called the Sepolia test network, which is the latest active test network of Ethereum. Let's select that, and it's going to basically shift to the Sepolia test network. Yeah, a question?
Yes, Ovia. So Anne is asking, what app is it that is used to send the API request?
No, whatever app that you're building. Let's say tomorrow you build a dApp, you can integrate your dApp to use these APIs that Etherscan has exposed.
Yeah, I think so. She's asking what is the source of these requests?
No.
From where can we send API requests?
From where I sent it, I tested it using this app called Postman. Or you don't need to even test Postman. So let's just copy this. You can just copy this and go to any browser and paste it, and you should be able to get the response. See, you got the response. So an API is basically, it's just the request string, right? It's a get request get string, which is just a URL, which hits the Etherscan servers and gets a corresponding response for you. So it should work with any browser actually. But I use the app called Postman. Right?
Okay, we have another question. We were asking what exactly is Postman?
Postman is just an app that is used to test any API request, get, post, put. So in development, it is often used, especially when you're creating a microservice architecture, and there are several APIs that each service exposes, and you want to test between them. You might, in larger projects, you use something called Postman, but for smaller projects, it's really not needed.
Got it. Yeah, I think we can go ahead.
Okay, cool. Right. So we were in the middle of moving to our test network called Sepolia. So we're in the Sepolia test network. And again, I have 0 Sepolia ETH. It's time to change that because it is fake money. We can all get rich. So I'm going to go to this website called a faucet. Faucet is a term used in plumbing, which just basically means a tap. So we're going to open that tap and get free flowing Sepolia ETH. So I'm going to go to Sepolia faucet. So this faucet is provided by one of the node providers called Alchemy. So again, in the diagram, we saw Infuria. Alchemy is yet another node provider, and they are just giving a free Sepolia ETH. But again, we want some resemblance to the main network. So even this is limited to an extent. You can only get a limited amount of Sepolia ETH per day. So if you want to test your projects, it's a good idea to go every day, once a day, and load your wallet. So I've opened sepoliafaucet.com. Maybe I can just paste the link on the chat. Okay, so in Sepolia faucet.com, I'm just going to open my MetaMask here, copy my address, and paste my wallet address over here. What is happening? Okay, so I have to sign in first because Alchemy wants to know who is creating the wallet. So I'm just going to sign in with my Google.
So Ovia, we have a question as to how do you convert your ETH to Sepolia?
Sepolia ETH, you don't convert. Sepolia is like a duplicate network of the Ethereum mainnet. It's not exactly a duplicate because it doesn't have the same data, but the structure, the skeleton of it is the same.
Got it. Okay.
Yep, I'm human. Awesome. It's gonna ask me. Okay, these questions are really tough. Who finds these questions easy? Okay, which contains a building? I think this one does, this one does, this one does. Okay, cool. And then, okay, so again, I'm going to copy my wallet address here and paste it over here and send me some ETH. Okay. So now let's watch what exactly happens here. So what is happening is Sepolia has an account on the this faucet Alchemy has an account on the Sepolia blockchain, and it's basically transferring some Sepolia ETH from its account to my account, which is the address that I'm sending. Oh, I haven't done this. Okay, again. Okay. Select all the squares which has a bicycle. This has a bicycle, this one, this one, this one, this one, this one, this one, this one. Does this one have? I think it does. Yeah, okay. Oh my God. It's just not convinced. Okay, cool. Send me ETH. So as I was saying, Alchemy has a wallet with a lot of Sepolia ETH, and periodically it's just distributing a little bit to people who come to its faucet. So it's basically a transaction, right? It's sending some money to me. And what kind of a transaction is it? We saw that it's basically sending native token. So it is a value transfer transaction, right? So we can even see this transaction on Etherscan. So if I can click, I just clicked Etherscan from here and it's opened up over here. And it's, if you can see, it has this is the wallet that Alchemy has holding the Sepolia ETH. And if you can see, this Etherscan is also slightly different. It's sepolia.etherscan. So they've just created a replica of Etherscan for the Sepolia blockchain. And this is my wallet address 07E, and it has sent me 0.5 Sepolia ETH. And it has paid a transaction fee of this much. Transaction fee is basically gas fee, what is gas fee? Gas units into gas price. And it is paid 5 so much way as gas price, right? So you can even see more details. We can even see all the aspects of the transaction that we saw. But yeah, that's pretty much it. So there we saw the from value, the gas price, and call data. All of this field is basically the call data field. And yeah, that's it. Okay. So let's check if we've received this money. Yes, if you can see your MetaMask, you would have received 0.5 Sepolia ETH. Who hasn't received it? And MetaMask is also showing that I've received this on June 22nd. Anybody else who's not received? Okay, let's move on then. So this is great. We've established a presence on the blockchain network, be it the test network, but it's still a blockchain network. We've seen our identity on the blockchain through Etherscan. We've got some native tokens into our wallet so that we can use it to pay future gas fees and perform transactions. So I hope all of you are following along. So let's talk about this tool called Remix. Now we come into Solidity. We're going to use this tool called Remix, which is a browser-based IDE to write smart contracts. Okay, so smart contracts are basically, so they are just a piece of code that contain a lot of functions. Functions are just codes that take input, does some processing, and gives out some outputs. So a contract has a series of functions encapsulated in this construct called a contract. Right? So now this contract can be written in several tools. Two popular tools are Remix, which is a browser-based tool, and Hardhat, which is you have to install it and to use it. So many smaller projects use Remix because it is easy. There is no setup required. But if your project is really complex, you have like a very complex folder structure with a lot of references and dependencies, you might want to go with Hardhat. But in this course, you'll be using only Remix. Now, given that you have these two tools to create your smart contracts, how do you deploy the smart contract in a blockchain? Right? These clouds are basically different kinds of blockchains. We saw ETH mainnet, and we created some funds in Sepolia test network. There are other EVM compatible blockchains where your same MetaMask can be used, which is an EVM based wallet. So Polygon is a layer 2, which is also forget that I said layer 2, I don't want to convince you. So it is also an EVM compatible blockchain. Now we can have several local blockchains. That is a single node blockchain. A blockchain, as I said, is a peer-to-peer network that it's there's distributed consensus among different peers in the network. But imagine that if the whole network had only one peer, you're basically, doing consensus with yourself, which is the easiest way of doing things. So the single node networks are Ganache and Remix EVM. So this is just to test and, check whether your code is working properly. You can avoid this whole peer-to-peer network complexity and just run a single node blockchain on your system to test out your smart contracts. So as I said, any contract to perform transactions, you will have to pay gas fees and you will have to sign the transaction. You can either sign using the MetaMask that we just created. You can use any other wallet provider. There are several wallet providers out there. You can use Wallet Connect, which is a wallet and app aggregator, or you can even create a public key, private key, and use a library from a JavaScript code to interact with the blockchain. So there are several ways of interacting and signing transactions and sending them to the blockchain, but we will be using something called MetaMask. For single node blockchains like Remix and Ganache, we can either use MetaMask and connect to those single node blockchains, or you can use the specific test accounts that the single node blockchains provides already. So Remix provides its own Remix accounts, and Ganache also provides several Ganache accounts with some test funds for us to use. So let us go. I mean, we might not, if we have time, we'll talk about Ganache, but mostly in this bootcamp, we will either be using MetaMask with Sepolia, or Remix MetaMask Sepolia, or Remix accounts, Remix EVM, or Remix MetaMask and Remix EVM. So these are the different ways we will be interacting with the blockchain in this bootcamp. Any questions?
None as of now.
Okay, cool. So as I said, Remix is very useful for smaller projects because it is a no code, no setup required, no installation required, no dependencies software. It gives you exactly like a VS Code interface. So it's very easy for developers to use on the get-go without having to learn anything. If you want, you can download a Remix desktop version, but it really doesn't give all features of Remix Desktop is also available on the Remix browser version. And the only difference is that in Remix Desktop, you can directly connect to your local file system, and any changes that you make in the desktop app will directly be saved to the file system. In the desktop version, it is a little bit complex. We will see how that is. Remix is really good because it comes with inbuilt templates for smart contract. You can just plug and play different templates and use it. And it also has great debugging and other tools that you can use. So let us see how Remix works. Again, I'm going to stop sharing my screen. So again, we have our browser over here. I'm going to open a new tab and say Remix. Just wait. Remix Ethereum. So if I Google this, the first link that comes right from ethereum.org, which is the Remix Ethereum IDE, this is what we want. So if you see, this is the interface. We can forget all of this for now. So this is how it looks. So if you see, it comes with a lot of project templates that you can directly use for ERC20, ERC721, multi-sig wallets. It has different plugins that we will see what they are. And you can even connect to your file system. You can connect to GitHub. You can connect to IPFS. But I want you to see, okay. So Remix, as I said, has a VS Code-like interface, and it comes with its own inbuilt terminal that we can use. And on the left-hand side, you can see different icons over here. The first is the File Explorer, which is also very similar to your VS Code. And then the second is the search. You can search in all your files. The third is the Solidity compiler. Solidity is a compiled language, so there is an intermediary form. You can compile your Solidity contracts into bytecode, and then the bytecode is what is sent to the blockchain. So you have a Solidity compiler, which basically compiles your code into an intermediary form, and then you can deploy and run the compiled Solidity contract. You can debug, or you can do unit testing if you like, and there are a lot of other stuff. Oh, this is learning. So if you can also learn Solidity through Ethereum, which is a really cool feature. You might want to explore it later on. And here is your plugins. So you can install different plugins. I have installed a few plugins. You don't have to install the same plugins that I have installed, but I've heard that this Solhint is a very good plugin to have. Solhint linter. So this will basically do a pre-compilation checking for you and gives you warnings based on how well you've written your code. This is a very kind of good plugin to have, I suppose. So now let's see how to connect to a file system. So I have some code over here. So let's see. Right, so this is my file system, and I have kind of put all the programs that I'm going to use in this location. So I'm just going to open this in my terminal here, okay? So now keep this open, and I want you to go open another tab and search for RemixD. What are we doing right now? We're trying to connect this Remix, which is a browser-based tool, to our local file system. So in order to do that, I need the RemixD, which I think stands for Remix Daemon, but I'm not sure. So yep. So this is it. This is it. Sorry, not RemixD. I'm going to search for Remix project. Yes, okay. This one. Yeah, first one. So search for Remix project. And yes, this is the correct link. So in Remix project, come down and it will show you RemixD, which is the command line tool. So I'm going to click on this and it will take you to the GitHub of the project, Remix project. If you come down, I hope everyone has Node installed. If you just a good way to just check whether you have Node is to type node space version and check if that works for you. So if you have Node, then you must also have npm installed. So a quick check, Bhavya, can you just ask everyone if they have it installed?
Yeah, I'm just running a poll for that as well.
Sure. Right. So for those of you who have Node and npm installed, I would just like you to take this command and run it. So you just have to in your terminal, you can just type node space hyphen version, and it should give you the node version you have. You can also do npm space hyphen version, and it will give you the node package. So npm is node package manager. So it comes automatically with your node installation. So once you have,
yeah, we have a question. Do we need an empty project for this? And wondering what file to open the terminal in.
Right, you can just create a folder, doesn't matter. I'm just showing you how to connect to your local file system. In future, if you develop a project and you have a folder with smart contracts, then this is how you would connect your Remix tool on the browser to that folder.
Okay, yeah.
Okay, so just take this line here. I'm going to paste it on chat also. Yeah. So I would remove this global -G. So just take this, copy this and just paste it over here. And I'm just going to remove -G because I already have this installed globally. So I don't need it. You also can choose to remove it if you like. It's not important. So npm install remix project remixd. So once that is done, yeah. So we're already in the location of our the location. So it's done. We're already in the location that I want. So I'm just going to type remix D here, and it has started the remix on the background. So this is ongoing. So now if I open remix in my browser and go to my file system here, and there is a default workspace over here. If I just click on that and say connect to localhost and say connect, automatically all the files that is there in the location where I'm running my remixd, right? It will show up in the left-hand side. Does everyone is everyone with me so far? So for you, it might be empty because you don't have any smart contracts here yet. But yeah, but it should be able to connect to the system. Now, a disadvantage here is now we are able to connect to the local system. But if I make a change here, it will not automatically reflect in my local system. And vice versa. If I make a change in the local system, I have to refresh this to get that change in my browser. Right? But for now, it's okay. We're not going to. I just showed you how to do this. Okay, so let us move on. Right. So we saw how what Remix looks like. We saw capabilities, how it can use templates, how it can use Power Plugin, and we were also able to connect our local system to the Remix. It was able to read files from our local system. So now we're ready to start writing smart contract with Solidity. So I'm going to introduce Solidity now. Solidity, as I said, is a programming language specifically designed for the Ethereum platform to write smart contracts. Right? So Solidity is very special because it is the first language that was completely written for smart contract programming. It is complete contract oriented. Every piece of code, every function is encapsulated in this construct called the smart contract. Yes, Bhavya.
Hi, okay, so Makai is getting lost on how the local connects to Remix. She's created a localhost workspace and installed Remix. Now she's not sure how to connect them.
Okay, you have a file, right? Maybe you can share your screen. Is that allowed?
I can add her and I can give her permissions. Yeah. Yeah, I have her here.
Sure. Okay, you can unmute yourself and tell me what the issue is.
Hi. Sorry, I just missed the step where you connect, where RemixD is reading from my local computer.
Okay. Do you want to share your screen if that's okay?
Oh, yeah. Let's see. Not seeing those options. It doesn't have the little option for me to share screen, just chat and, oh, I see.
You should have it now.
Okay, there it goes. Okay, it says I cannot start sharing.
I'm going to stop sharing so that you can.
Thank you. Okay, can you see? Oh, I don't know if it's the right screen though. Okay, great.
So,
So I,
can I see your terminal?
yes, it's right here on the right side. Can you see that?
I think it's hidden under the browser. So, okay, cool. So are you there? Are you there in the location that you have your smart contracts? I mean, what is there in this blockchain folder? Nothing, is it?
Yeah, I just created this. So do I need to navigate to this?
Okay.
In here?
No. So now just go, just type in the terminal, just type RemixD.
In my terminal?
Yeah, RemixD. Yeah, just run it.
Oh, okay. I missed that part.
Yeah, so now it's running. Now go back to your browser.
Okay.
In the top left corner, can you click localhost? Yeah, just connect to localhost.
Okay.
Host, then connect.
I thought I just had to create a workspace. Okay, I see.
Space here. So any file that you add to your blockchain folder, you can just disconnect from localhost and connect it again, and it will show up on your Remix.
Okay, and I just connect through here. Okay, so I'm going to delete this one. Okay, great. Thank you.
Okay. All right. So I'm going to share my screen again. One second. Yep. Can you see my screen now? Okay, cool.
It's loading. Yeah.
Okay.
Now we can.
Right. So we were talking about Solidity and how cool it is. Yeah. So again, Solidity was one of the first languages that was completely created for smart contract development. So everything you write in Solidity is encapsulated in something called a contract. It is statically typed. That means any variable that you define on while coding Solidity has to have the data type defined at compile time. So while compiling the code, it should know what data type each variable is. It cannot figure out the data type like other scripting languages like Python at runtime. So you need to define exactly what data type each variable is, so that it can allocate the appropriate memory to it. This is very important because in when you think about programming in the Web2 space, we don't focus so much on memory. We are all about, reducing the time complexity. We want that efficient, low order of 1 or order of log n kind of time complexities. So when we're coding for the blockchain, memory is also important. Like time is definitely important, but memory is also important to an extent. So that's why we need to allocate space for every variable appropriately. So again, Solidity is built specifically for the Ethereum ecosystem, Ethereum family of blockchains, all blockchains that are EVM compatible. So it can only be compiled, it can only be understood and executed by the Ethereum virtual machine. So any other blockchain that does not use the Ethereum virtual machine will not be able to understand the Solidity language. It has very good development tools. There's a very good community behind Solidity. There are a lot of developers and projects out there that are built on Solidity. So you're in a good happening space right now. I wouldn't say it is completely saturated, but it has a very healthy community around it. So it's a good idea to learn Solidity. It considers security aspect and is widely adopted. So when you write Solidity code, you compile it into something called a bytecode, and then you deploy this bytecode on the EVM. And EVM, whenever the contract is, so when you deploy it, the whole code is tested once, it's executed once. And every time the Solidity code is invoked, the particular function is also executed on the EVM. So this is how Solidity works. Every Solidity file has the what do you call it? The extension of .sol. That's how you identify a Solidity file. And Solidity has taken inspiration from scripting languages like JavaScript and from object-oriented languages like C++. So you can find, if you know one of these languages, it's very easy to understand the Solidity. Even without learning it properly, you'll be able to at least figure out logically what is happening in the code. Yeah. Moving on. So in a Solidity contract, you will have several aspects, and this is the order in which you can write them. First, you will have your license. Then you'll have something called the pragma derivative. Then you'll have all your imports, which are other Solidity files that your current Solidity file will invoke or call, it will refer to, will reference basically. Then you have interfaces, which are like abstract classes in Java, if you're familiar with, even interfaces are there in Java also. So it just basically has function signatures without the actual definition of the function. Then you have the contract declaration, which is the keyword contract. And then you have, so contract is, you can compare it to a class in object-oriented programming. A class has member variables and member functions. So even a contract has state variables and functions. So you have a list of state variables here. You can have structs, enums also. There are additional things called events and modifiers. We will come to that. You already know what a constructor is, which is similar to Java. And then you have a list of functions. And then you have special functions called fallback and receive. Then you end your contract. So this is how, if you take any .sol file, this is all the things that it can contain. So we will go into each of these in detail. Yeah. So first, before we start, I want to talk about Solidity comments. So comments in Solidity comments in any programming language is very, very useful. It helps readability and it helps in maintenance of that code. In Solidity is no different. You can have comments in Solidity also. Normal comment in Solidity is written as 2 forward slashes and followed by whatever content you want to write. So this is a single line comment, and you can have multi-line comment as /* with whatever comment, and then ends with star and /. But there is a special type of comment called the NatSpec comment, which is the natural language specification. So those comments have to be defined like so. The single line comment is 3 / and the multi-line comment is / and but it ends in star /. So this is how you write NatSpec comments. On the Outlook, it looks normal only. There is no difference between NatSpec and Solidity, but you can have special commands in the NatSpec comment that can be used for documentation purposes. So given a code with well-written NatSpec comments, you can instantly derive you can extract documentation out of it. So if you want to learn more about what a NatSpec comment is, or anything related to Solidity for that matter, I want to introduce you to the Solidity documentation. So you can just go to your browser and hit Solidity docs. So Solidity docs. So this is a very good, well-documented site for the Solidity language. It is up to date with this latest stable version of Solidity, we're in the major version 0.8. Minor version doesn't really matter, but I would suggest you compile all your Solidity code with 0.8 as of today. So anything you want about Solidity, you can look it up in Solidity docs, and this is the only place I would trust to know everything about Solidity. So in search docs, you can just type NatSpec comment, for example, and it will show you. Yeah, so you can NatSpec format. Okay, so you can basically read up what NatSpec comment is and how, as I said, it has nice commands that you can give, parameterizations that help you derive very good documentation very quickly. So in your larger projects, you may want to consider it. So coming back to our thing, so we saw what Solidity comments are. Solidity licenses. So this is the first line of the Solidity program. It's written in a comment. So this is the exact syntax, SPDX license identifier : and this value can change based on what license you want to give. There are 4 different licenses that you can give: MIT, Apache, or you can also give no license. But yeah, it's a good idea to have a license. So this just helps in the distribution of this code at a later point of time. Now the next is the pragma derivative. Pragma derivative is basically it tells the compiler which version of Solidity compatible code that you have written. So for example, here I've written in this line, you can see pragma Solidity and the number, right? So when you compile this code, it will know which compiler to pick, which version of the compiler to pick to run this code. So there are different ways of writing this pragma derivative. If you put the cap here, it means you can choose a Solidity compiler version greater than or equal to 0.8.0, but less than the next major version. So you can take anything above 0.8.0, but not 0.9 point something. So that's what this means. And this is the most common line that is used. You can also write other, like you can say anything greater than 0.6, but less than 0.9. Or you can say use exactly this Solidity version also. Solidity compiler version also. These are different ways, but most commonly, most code you will find the first part, which is the cap based. And it's not a good idea to write exact version, because then your code will only need that compiler, and that is a dependency you don't want to create. Okay, imports. Imports are statements, other Solidity files that you want to reference to. Maybe there may be some functions that are written in other Solidity files that you want to use in your Solidity file. And for that, you use the keyword import and you import the other files. For example, import opens up in Solidity ERC. So this is an important, very common import statement that is used for ERC20. We will see what ERC20 is at a later point of time, but this is generally how you write an import statement. For now, let's not worry ourselves with this. But note that if you write an import in a local system, then this is the path of the file in your local system. So when it gets deployed, you won't basically take your file system onto the blockchain, right? So that exact code will be referenced from this path and it will be copied into that Solidity file, and that Solidity file is what is deployed to the blockchain. So if you're going to write import on your statement, then you make sure that the path to the Solidity file is correct over here. The imports are very important because you can make your code modular. You don't have to have one big long file with all your functions. You can compose it into specific features of functionality. So it's time to look at our first contract. Let's look at a simple contract called storage.sol. I'm going back to my remix, and I've taken some set of contracts from one of my good friends. So I just want to use, and I think they're very well written and very easy to understand. So I hope you can all see this. Is this good? Okay. So this is a very simple smart contract that will store this variable num on the blockchain. The blockchain will maintain the state of this variable. So every time there is a change in the state in the value of num, it means that the blockchain state has changed, and that will involve a transaction in the blockchain. So we have a contract called simple storage. So as we saw that this is the license identifier, this is the pragma derivative, this is the contract keyword. This doesn't have any other imports or nothing, none of those complexities. You have the contract keyword and the contract name. And if you notice, the contract name is written in camel case. I hope everybody knows what camel case is. Camel case is basically title case, where the first letter of every word will be capitalized and the remaining letters will be in small. If it is a contract name, then the first letter is also of the first word is also capitalized. For variable names, it is still camel case, but the first letter of the first word is still is small. So that's what camel case means. It's an alternative to snake case, which is often used in Java, where every word is separated by an underscore. That just makes it too long. So we use camel case in Solidity. So after that, you have a normal comment over here, and then you have state variables. Okay, like a comparison to class. Again, class has member variables and member functions. So here we have state variables. So the state, as Solidity is statically typed, you are representing what data type this variable is, which is an unsigned integer. Unsigned integer means integer which is above 0. It is always a positive integer. Public will come to what each of these words mean, and you have a variable which is called num, whose state is maintained by the blockchain. And you have some functions over here. That basically here, this function will set this variable to another value, and this function will just read the variable. So this is just a read-only function which will not take gas to execute. This is changing the state of the contract, so this will take gas to execute, right? So as you can see, the Remix is trying to estimate how much gas this function will take. So this is a good way to write optimal code. So Yeah, so one more thing I want to bring your attention to is this underscore. So as I said, we use a camel case and we don't use underscore, but this is a practice that is used in some programming languages, including Solidity, to differentiate arguments from the variables. So what is the difference between parameters and arguments? They are often used interchangeably. Parameters is this is actually a parameter. When you write the function, all the parameters, all the inputs that the functions take is called the parameters, right? But when you invoke the functions, the values that you pass into the function invocation, those are called arguments. The actual values that are passed are called arguments, and during the definition, the inputs that you write are called parameters. So to differentiate the parameters from the actual state variables, you use the underscore. Usually the parameters are written with underscore. So here we see that when this function set is invoked, the parameter underscore num, the value that is sent here, the argument that is sent here is the value set to the state variable num. So this is the smart contract. So let us execute this using our MetaMask and see this transaction on the blockchain. So as I said, contract deployment is a transaction, and invocation of a contract is also a transaction. So let's see how that happens. So first we need to compile it. So it already says there is a warning. What is the warning? So let's just comment this line for now, because this is a warning because we've created a variable t and we're not using it anywhere. So I'm just going to comment out this line. So as you can see, I've set auto compilation on. So automatically this contract is compiled and it has given me a tick. What is the output of the compilation? It is a bytecode, right? And you can see this here. There are two outputs to any Solidity compilation. One is the ABI file. We'll talk about more about what this is in upcoming classes, and a bytecode. This bytecode is what is actually sent to the blockchain. Now we have our bytecode. It is time to send it to a blockchain. So we saw that there are several ways of interacting with Remix to the blockchain. We can use test networks like Sepolia using MetaMask via Remix, or we can also use the local Remix VM. So first, we've already created the MetaMask wallet. So let's see how to integrate MetaMask into Remix. Okay, I hope you guys are following along. So now I'm in the process of integrating MetaMask to Remix. So now I'm going to go to this icon over here, which is the deploy. I'm going to click this. And so now there's a field called environment, and I'm going to say injected provider over here. When I click injected provider, automatically it recognizes MetaMask and asks me to connect to MetaMask, and it asks me which account of MetaMask I want to connect. Yes, I want to connect this one. It has my correct address 0E7, and it knows that I have 0.5 Sepolia ETH balance. So I'm just going to connect it. Connect. Now, automatically, if I deploy whatever account this MetaMask, whatever blockchain this MetaMask is connected to. Right now, I'm connected to the blockchain Sepolia test network. So whatever this blockchain the MetaMask is connected to, automatically Remix will be able to interact with that blockchain via MetaMask. So now, again, I want to deploy the simple storage contract on a blockchain. So you can recognize many of the fields over here. Gas limit is the total number of gas units a block can hold, or a transaction code can hold. So now we're not going to send any value here. This can be empty. This is the contract deployment transaction. So I don't want any balance. Even though this contract will have an address and a balance, I don't want to send any ETH here. So I'm going to leave it as it is. What contract do I want to deploy? I want to deploy the simple storage.sol. It's a good practice to keep one contract per Solidity file and give the name of the file the same name as the contract. This is not compulsory, but it is a good practice. So now I'm just going to click on deploy. So when I deploy, this is a transaction, contract deployment transaction. So it requires gas fees. So rightly, we know that we're using, it says that I have 0E7, which is my account, and it has 0.5 Ether balance. So to deploy this contract, it goes as a transaction and it is going to cost me so much gas. So MetaMask has automatically calculated how much gas units I need for this transaction and how much gas price I need to give for this transaction to get into the network. So I'm going to try. So this says that at very likely, that is within less than 15 seconds, this transaction is going to enter a block on the network, right? So to do this, I have to pay this much fee. So if I don't want to pay, if I want to reduce the fee that I want to pay, then this probability will also reduce. The probability that of this transaction entering a block also will reduce. But since today we're just using fake money, I'm just going to trust MetaMask and say confirm. So I'm paying 0.000437 Sepolia ETH to deploy this contract on my Sepolia test network. So when I confirm, so this transaction has confirmed. Yeah, so now this transaction has confirmed. So when I say transaction has confirmed, that means it has entered a block in, it has been sent to the Ethereum blockchain and it has a transaction hash. So as I said, every transaction on the Ethereum blockchain will have a transaction hash. So let us copy this transaction hash and see it on the Sepolia test network. So I'm going to sepolia.etherscan.io. Right, I'm going to go to Sepolia here, go to the home page, right? And I'm going to search this transaction. So this transaction is a contract deployment transaction, which means there is a contract that is created here, right? And there is no zero value that was sent. And this is the transaction fee that I paid, and this is the gas price that I paid. Right? You can see other details also here. And now this transaction has a call data. I can see this call data in, let's say I see it in UTF. I can't see it in original. Okay, let me see in UTF. Sorry, default view. Okay, so this is basically the concatenation of all of the above fields. There is a way to read this. Okay. And so this is how this transaction looks. Let me go back to Remix. So now we saw that this transaction has gone through with all of this simple storage dot gas. Okay, so awesome. So this has happened. So we should be able to see the contract also, right, on Ethereum. Okay, so now let me copy this and go to Sepolia transactions again, home. So, oh no, sorry. Yeah, sorry. Now that the contract has deployed, we have the simple storage dot contract deployed, and the address of that contract I can copy over here. Deployed contracts, I can copy the address and I can search for that address. I can search for that address in, yeah, I can search for it over here. So this is the simple storage contract. This is the contract that 2 minutes ago, the contract was created. And I go to the contract, I can see the bytecode of this contract. Okay. I can also verify this contract. So if I say verify, I can basically select the compiler type, single file. What license did we give MIT? So enter the code below, it's asking me. So if I can just copy this code. This is not needed. It's just an additional step to verify. So if you see all major protocols that have smart contracts, they will always have verified contracts. That basically says that you can look at the code of the contract. Otherwise, you'll only be able to see the bytecode if you don't verify a contract. If you verify a contract, you'll be able to see the actual code of the contract. So I can also give the ABI encode, which is, if I go back to my compile, I can just copy the ABI from here and go back to this and paste it here. Yeah. So, oh my God. Okay, unable to generate the. Okay, anyway, we will do that to save time. I'm not going to go into the details of this. So let's go back to our Etherscan network, and we were just looking at this contract. So we can see that the contract is being recognized by our Etherscan testnet. That means it's been deployed properly. So we will be able to interact with this contract. What I mean by that is, so now if you see the functions of this contract, which is, it has a member variable, which is num, which is public, and two functions, set and get, which are also written over here. So if you see, one of this is in red and one of this is in blue. Blue means it is a read-only function. That is, you can just read it without, you don't need it to spend any money to interact with this. Red means it changes the state of the contract, so you need to pay gas fees to interact with it. So we can easily get the value of num. You're calling the value, you're calling this, just reading the state of this num, and the value is 0 now, because the default value for integer is 0. You can also get this value, and again it is 0. You want to set this value, set takes an argument, which is underscore num. Let's say I want to set it to the value 5. If I call set, again, I have to sign it because it is a transaction. Now, if I confirm again, it calculates the gas fee for me. This is the contract invocation function transaction that we're doing. So now the set operation, the transaction is confirmed, and we can also view it on Etherscan. So let us just refresh this. So if you see, a contract was created. Now we performed the method set on it about 9 seconds ago, and it was executed with this much transaction fee. And now let's get the value again, and you can see that the number has been set to 5. So this is how we've deployed a contract on Ethereum or Ethereum testnet, and we have interacted with it. Now, this is a very complicated way of doing things, and I mean, this is how we normally do it. But for our testing purposes, we don't have to spend our testnet ETH and sign it every time, and we want a faster way of doing things. So instead of relying on the blockchain, we're going to use a single node blockchain, which is our Remix VM itself. So in our compiler, so we have done, so in our deployment, right, we already have the bytecode. We've compiled the contract. So instead of using MetaMask, which is connected to Sepolia, we're going to use the Remix VM itself. So Remix provides several local blockchains. So we're just going to connect to any one of those. And it also provides several addresses with some test ether for us to play with. So let's say I'm connecting to DC4 address with 100 ETH and I can deploy it. It's going to take the same thing. It's executed and it has taken some balance from me for gas fees. So I can do the same thing again. You can see that the contract address also has changed, and I can do the same things again. I can set it to the values. If I get it, it'll be 0. I can set it to the value 6. I can get it again, and it'll be the value 6. I have done all of this again without using MetaMask, just in my local system. So I have a single node blockchain. Now coming back. Right. So we saw a sample contract. We deployed it on our testnet. We also saw how local Remix EM works. So now let us all quickly see how gas works. So I'm not going to do this whole deployment and testing it out on all the contracts. I'm just going to show you the code, and I will share these files with you through Bhavya. Maybe she can mail it to you guys, and you can play around with it till next week and tell me if you have any doubts. Okay, so let's look at gas, how gas works. Okay, so this is a very simple contract again to study the workings of gas. So here we have a contract which has some public state variable, and you have a function called forever, which just runs a loop forever. So ideally, we are wasting the validator nodes. Anybody who invokes this function it'll go on and on and on, and the function will fail. Right. So I'm just going to deploy this in our Remix VM itself. So first let's compile it. It's compiled. In deployment, we're going to use our Remix VM. We have 99.99 gas. Let's deploy. Deployment should happen. But when we invoke this function forever, right? So we can delete our simple storage. We have the gas contract now, gas.sol. Let's delete this also. Yeah. Yeah, so we have the variable I, which is basically 0. But if we invoke the forever, we should run out of gas and the transaction should fail. So it is pending. And after a time, it will run out of gas and the transaction will fail. This is what I wanted to show you. So this is how we are protecting validator nodes from running a transaction forever. So after a point of time, it will definitely fail. It will take a long time to finish this gas limit, but it will never get confirmed. Okay, so let's maybe halt this one out. How do I do that? Cancel. Yeah, so it failed now. If you can see, the transaction has failed. And if you see the reason for transaction fail, yeah. See, the gas that we've provided was so much, and the execution has almost touched this amount. That's why it reverted the input. So we've utilized all this gas. We didn't get back any of the gas. So if you see, we didn't get back any of the gas. But since this is wave, we are not able to see the final few numbers. But we've lost so much gas in wave, and the transaction has failed. Okay, so next thing I want to show you guys is functions. Now we're coming to what are functions. Function is basically, you have the keyword called function, followed by a function name, and then a set of parameters that you take for the function. The parameter should have the type of the parameter, followed by how you want to store that parameter. We will see a little bit of this in the next session, and what the parameter name is. We'll talk about visibility in this session next in the following slides, and set of modifiers. We'll also talk about this in the next session. and what the function returns, what is the output of this function, and the exact function definitions. This is how a function is defined in Solidity. So every time a transaction is executed, right, a function is called during a contract invocation transaction. So when a function call is made, a set of values is passed along with the function call. When you do a contract invocation transaction, you pass some parameters to that function call, and that can be used in the logic of the function, right? So those are global variables. Global variables, if you want the exact list of global variables, again, the best place to see that would be the Solidity documentation. So yeah, so here you can see globally available variables. If you just search for it, it will come, and you have a list of all the variables that you can use in the transaction. But I just want you to focus on these 5, which are very popular. Block.timestamp is the so in Ethereum, blockchain works on Unix timestamp, which is the number of seconds that have passed since January 1st, 1970. So that is the how time is measured, and the lowest unit of time is seconds. So number of seconds that has passed since this this date, midnight of 1st January 1970, is how you store time. And timestamp stores the value of the time at which the block was created. Remember, all these parameters are coming to you during contract invocation. So that means it's coming to you in a transaction. And this transaction is executed by the validators when the proposer has added it into his block, and the validators are verifying it. So this block.timestamp is basically the time at which the proposer sent this block. The proposer created that block. So this is the time at which the proposer of that block in which this transaction is included has added his timestamp. So this is a very unreliable way of measuring time. It's not accurate at all. So we have the 15-second rule in Ethereum, where we know that blocks come every 15 seconds. So if you take the timestamp or something, you should always give a plus or minus 15 seconds margin to whatever use case you're using that time for. So it is not a very accurate representation. Next is message.value. So in a transaction, we know that there are several fields like nonce, gas price, gas units, all of that. Value is also one of those fields. So the message.value will give the value in the value field of that transaction, which is invoking this function call. So that is what message.value gives. It is given in uint. It's basically the number of ways sent with that message in the value field. Message.data is the call data. There is a call data field also for every transaction. Whatever the byte string in the call data field is, that is what you get in message.calldata. Message.sender is the address of the person calling this, invoking this function. All this data is coming to you, let's say, from a contract perspective that has the function that is being invoked. Somebody is invoking that function, right? Who that somebody is, that could be another contract address, or it could be an externally owned account. That is called invoking a function. So the address of that the account that is calling is called a message.address. Transaction.origin is the first address that initiated this transaction. As I said, every transaction has to be invoked from an externally owned account. So it could be a chain. So this externally owned account would call one contract, that contract calls another contract, that contract. It could be a chain of invocations. Message.sender will just give the previous caller, previous account address that invoked this transaction. Transaction.origin will give the address of the externally owned account that initiated this transaction. So I hope that difference is clear. And these are the more global variables that you might come across most often. So let us look at another example. I'm going back to my Remix and let's look at variables. Okay, so now there are several types of variables. Right. Yeah, so I want you to look at two types of variables, the state variables. As I said, contract stores this on the blockchain, and any change to the state variables is a transaction on the blockchain, and it causes the state change in the state of the blockchain. So these are state variables, and there are local variables that are there in the function. So the scope of this variables dies with this function. So these are not maintained by the blockchain. They don't have a space in any of the trie nodes that of any validators who are storing the state of the blockchain. They just die with the blockchain. Yeah, so as you can see, block.timestamp is used here, which is a global variable that we just saw. Message.sender is used here. That is also another global variable that we saw. So these are all about variables. Now let's look at something called constants. Now constants are also like variables, but they cannot be changed once they are set. So a constant is a variable that it is set, the value is set at the beginning. It's a state variable whose value is set at the beginning and it cannot be changed. So you can just use my address throughout the function without reassigning it. Now, by practice, all constants are written in capital case. So these are constants. Another thing is immutables. Immutables are very similar to constants, but the value is assigned at runtime. Again, once it's set, you cannot reassign it, and but it can be set during runtime. But for constants, the value of the constant should be known at compile time itself. You can't set it at a later point of time. And so these variables, right, these constants and immutables, they usually have primitive data types, which means data types whose memory location is fixed, right? They're static memory location. Okay, one more thing is constants can be accessed. These are immutables. Constants can be accessed globally, even externally to the contract, but immutables can only be accessed inside that contract. Okay, so these are the difference between constants and immutables. Okay, another aspect of Solidity I want to introduce in this today's session is view and pure. Yeah. Okay. So a function can be defined view or pure if it is a read-only function. Both view and pure are only used for read function. That is, if a function is changing the state of the blockchain, then it cannot be view or pure. But when do you call a function view and when do you call a function pure? View is when you're reading some state of the blockchain. So this function is using, that is, it's reading a state variable, but it is not changing the state variable. That is view. If it is not reading a state variable at all, then it is pure. So here, if you see, this function add is using this parameters I and j and returning a value. It is not using anything that is stored in the blockchain, like this variable or any other. It's not calling any other functions. So this is a pure function. A view function, it just takes a value y and it is adding to the state of the blockchain x. X is maintained by the blockchain, so it has to read from the blockchain. So it is a view function. If you don't write view or pure, automatically it'll assume that it is not, but it's a good idea to explicitly write view and pure, because the way these functions are stored and it just optimizes the storage a little bit. So it may help in reducing gas fees for you. So that's why you write view and pure. I hope that is clear. There's not been many questions for a long time. I still had a lot of things to complete today. Maybe I'll just finish with visibility. Okay, I'll take not more than 15 more minutes and I'll finish visibility and primitive and reference data types. Okay, function visibility. Is that okay, Bhavya?
Yeah, that should be fine.
Okay, so now we're coming into, so we know what functions are and we saw what variables are and pure view variables and pure variables and what are constants, what are immutables. Now in functions and variables, we have something called visibility. That is, who can access these functions and variables. So there are 4 types of visibilities for functions. Functions can be called public, private, internal, or external. But variables can only be called public, private, and external. I think I made a mistake over here. It should be public, private, and internal. External is not there. Yeah, okay. Let me just, okay, guys, there's a typo here. It is internal. So basically functions can be public, private, internal, and external. Variables can be public, private, and internal. What do they mean? If a function is, let's start with external. External functions can only be called from another contract, outside this contract, or another external, another account, basically, another contract or another externally owned account. So only they can call these functions. That's why that's if a function is defined as external. If the function is defined as internal, only the contracts, only functions that are internal to that contract can invoke this function. No other external account can invoke that function. Internal accounts, even if a contract is inherited, again, an OOPS concept, if you're familiar with Java, C++, you would know what inheritance is. We will also learn about what inheritance is in later classes. But basically, one contract is derived from another contract. Derived contract can also access internal functions, but no external contract can invoke these internal functions. Now, public functions. Public function means any party, all parties within the contract, outside the contract can invoke the function or see that variable. If a variable is defined as public, anybody can see that variable. And by default, a function is public. If there is no visibility given to a function, then by default, it will become public. Private. Private means it's only visible inside the contract. Even inherited contracts can't see them. No external contracts, external accounts also can see them. So they're only internal to that function, only they can be accessed. For state variables, by default, if you don't specify a visibility for state variables, then by default, they're internal. If you don't specify a visibility for a function, by default, it is public. So I hope this 4 visibility concepts are clear. Moving on. So now we have 2 types of data types. One is called primitive and the other is called reference data types. Value type and reference type. In value type, the size of that data, of that variable is defined. Exactly how much memory positions it will occupy is determined at compile time. Now, but for reference data type, it is dynamic in size. It can grow dynamically. So the size cannot be allotted at a compile time. So some examples of value types are booleans, integers, unsigned integers, enums, address. All of these are value types. That is, they have fixed memory positions that they occupy. Reference type is dynamic in nature. Arrays, structs, mapping, string. All of these are reference type. So this matters in the way they are stored in memory. So let us go into the detail. We know what enum is. I will try to focus on aspects that are new to Solidity, and everything that is common to other programming languages, I'll just gloss over them. So enums are very simple. You define a set of states, and each is assigned values from 0 to how many ever they are. And if you use this word pending or something in the code, automatically it means 0. Now let's specifically look at the address, because that is specific to Ethereum. Only in Ethereum, in the smart contract way of programming, we come across this address type, which basically we know that it can mean externally owned accounts or contract accounts. Now, address type has two types. There are two types of address types. One is called the normal address type, and one is called address payable. There are two types of addresses, address and address payable. They are not equal to each other. They are both two different data types. The address data type, they both occupy the same amount of memory. That is, they still they have the same value, as you can say. So they occupy the same amount of memory, but only address payable can receive Ether, right? So remember that. We cannot send any money if something is declared as address type. It has to be typecast into address payable to receive Ether. And you can typecast from one to the other. If you want to typecast address payable to address, then you just use address of, and this will be an address data. A will be an address data type in the first instance. If you want to typecast to address payable, then you use payable typecasting over here. And the balance field is common to both, and it will store the value in way. But address payable has two extra fields called transfer and send. So we'll see what they are. Before that, let me just quickly show you what primitives also is. So in this set of contracts, we have a contract called primitive. Now in this primitive, you can see different primitive data types. We saw that Boolean, integer, unsigned integer, enum, address, all of these are primitive data types. That is value types which have fixed memory length. So if you see bool, uint ranges. So if you declare a variable of the data type uint, that means it can store a limited set of values only. Basically, it has limited bit spaces that it can occupy. So when you convert it, it can only store 0 to 2 to the power of 8 minus 1, because it only has 8 bits of storage. Similarly, uint 16 means 16 bits of storage, so it can only store 2 to the power 16 minus 1. So by default, we use uint 256, which has the largest space basically. But I will, when we have to think about what data type we're assigning. I mean, it may be easy for you to say, let's just store everything in uint 256, because I mean, I don't have to worry about what is the range. So again, all of this matters in gas optimization. So when you go into advanced Solidity programming, you will have to think about all of these minute things when you're coding your Solidity contract. So you can make gas efficient for you and also the person interacting with your contract. Again, there is int 8, same concept, but it goes both ways. It can even accept negative values. You can find if you're not sure of what is the minimum and maximum value that can be stored in that in your data type, you can just use this type int.min and .max function. Again, address data type stores a value like this. All default values. Default Boolean value will always be a false. If you don't assign it, then and if you try to use it, it will be a false value. Default int and unsigned integer value is 0, and default address value is always a complete hexadecimal with all 0 positions, right? So this is just examples of different primitive types you're going to use. So I want to show you how address data type works. So I have this contract called payable over here. Now here in payable, we are looking at the address type. So there are two different types, as I said, address and address payable, and only address payable can receive ETH. How do you declare an address payable data type? You have to write address payable as the data type, and then define its visibility and the name of that variable. So in a constructor, and again, they have typecast. So message.sender is the address of the last account address that who's invoking this function. So it's a global variable that we saw, and we have to typecast it as payable to send money to it at a later point of time. So this is a function. And here even a function is declared payable. If you're using address payable in a function, then the function also has to be declared as payable. If you don't, so if a function is not declared payable, then you cannot send money to it. So if this function receives a transaction with a non-zero value field, then the function will fail. So if you want the function to accept money in the value field, then you have to declare it as payable. Okay. So now if you see, it is taking, it has, yeah. So in this withdraw function, what it wants to do is take the balance of this contract and send it to the person who called this function, or send it to the owner of this contract. So we know when we created the contract, this is a constructor. Constructor is similar to any other programming language. It is a function that is invoked only once upon forming in object-oriented programming. When you create an instantiator class, that is when you create an object, you call the constructor. Here, when you deploy the contract, you invoke the constructor. So the constructor is always executed upon deployment of the contract. So when you deploy the contract, the person who's deploying is set as the owner here. Now in this function, it is basically sending whatever balance this contract has. Contract also has an address which has a balance field. It is sending all that money to owner. So as I said, address payable has extra fields called 3 extra fields: call, transfer, and send. And we will see what these are. Call basically takes a value parameter and executes a value transfer transaction. So it basically takes the money from this contract and sends it to does a value transfer to the owner with the whatever amount. Amount is basically this dot balance. So from the contract is executing this. So the from field will be the contract address. The to field will be the owner, and a simple value transfer transaction is executed over here in call. And the call will return a success value if the transfer is completed, or a fail error if the transfer is not completed. The other 2 types of transactions are send and transfer. So let's see what the difference is. So same concept. You have somebody payable. It could even be the owner, doesn't matter. In this example, in the above call, we saw owner. Let's just take any payable address. The address that you're, it has to be payable. So that's why they've declared address payable as 2. So from this contract, you're sending to this address an amount. Now this send and transfer is very similar to each other, but send will return an error if it is a Boolean value true or false if the transfer is successful. So if the transfer is successful, that is the contract has successfully sent so much amount to this address, then this Boolean value will be set to true. But in a transfer, If the transfer doesn't happen properly, then it is an error and the transaction will fail. Here, the transaction will not fail. It will just set this Boolean true or false, and the execution can proceed. So that is the only difference between send and transfer. But what is the difference between call and send and transfer? Call will send only native token. It will take the value field and it will take the native token. It will send a native token. But in send and transfer, you can send any other, anything else. So here you're sending it as a value transfer. Here you're sending it as a, like an invocation. So that is the difference between call, send, and transfer. I hope that is clear. So we saw what the address, we saw what primitives are, we saw what enums are, and we saw what address and address payable means. And if you want any account to receive money, then in the value field, it has to be receive any kind of thing, it has to be any kind of money, it has to be declared as payable. If you want to a function to receive a value field, then it has to be declared as payable. And additionally, address payable, we saw that there are extra functions called transfer, send, and also call. So there are 3 types of additional things that you can do for address payable. Okay, arrays. Arrays are reference types. Again, as I said, if the memory slot is the number of slots in memory you need for that variable is decided at runtime, then it is dynamic allocation. Basically, it is a reference type. We know arrays from many other programming languages. It has a length field. You can basically decide how many values are there in the array. Push of a val will insert a value at the end of the array. Pop will remove the value at the end of the array. Strings. So we'll quickly see strings. Just 2 more slides and then we'll stop for today. So strings, I hope you're able to see my screen. Strings are also very similar to any other programming language. You can create a string. You can do 2 functions with strings. You can do a compare operation, which will just compare 2 different strings and return a Boolean value for you. And concat. Compare is comparing. Concat is joining 2 strings with one another. I mean, this is a very straightforward thing. You can go through it yourself. I'll go back to my slides. A struct is also very similar to any other programming language. A struct is a user-defined data type, which means that you can you can collect different attributes for something together and put it as a user-defined data type. You can have an array of structs where you can just push things into the struct. How can you initialize or a struct? You can do it in 2 ways. One way is you can just call to do, and it has an inbuilt constructor where you just have to give everything in order. Let's say text and false. So if you give an order, it will automatically initialize the struct. Or you can do in a key value mapping. You can give text as _text and complete it as false. Here the order also can change because it is a key value mapping. You can also initialize an empty struct and then update it later on with dot operation. So you have an empty struct over here. You can do dot text is equal to something else. And if it is not initialized, then it takes the default value, and we know that the default value for Boolean is false. Okay, the last reference type that we're going to be looking at is mappings. Mapping is very similar to a Python dictionary, which is basically a collection of key value pairs. Okay, maybe I shouldn't see that. So it's basically key value way of storing things. So how you declare mapping is you take mapping and you specify the data types it maps. Here I'm mapping an address key value to a uint value So this is the key, this is the value. The key is of type address and the value is of type unsigned integer. So this is the key value mapping that you can do. How can you reference a mapping? So this is the variable name, which is my map, and if you can refer it by the key value, like how you would do a Python dictionary or any other key value mapping. So you can access the elements like this, and you can also have multi-dimensional mappings, like a 2-dimensional, 3-dimensional, where here you will have address mapping, the value would be another mapping. And every time you add a mapping to the value field, it will just become multi-dimensional. So we will see an example of this quickly. So let's go back here and see mappings. So here we have a mapping, which is an address and an int, my map. And here you're retrieving some element from the mapping. Okay, nested mapping is the multi-dimensional mapping I was talking about. If you do mapping of an address and the value field is another mapping, then you have 2-dimensional mapping. So how would you retrieve elements in this mapping? You will just have a 2-dimensional thing, like you can call it like this. The first dimension would be this address, and the second value would be this uint. And then this whole thing would return a Boolean. This is how you would reference a multi-dimensional map. So please go through this file also. I'll share them with you. They're all fairly simple. You can actually play around with it. You can deploy it using MetaMask or using Remix EVM and see the transaction on Etherscan. You can play around with the functions. One quick thing that I want to talk about is payables, right? So in payable, if I deploy this transaction, let me just delete all the other ones that I have over here. Okay, now I'm deploying this payable transaction in Remix VM. Right here, if you see, yeah, here I talked about blue and red, but now we have an orange also. So what does this mean? Blue means it's just read only. You don't need any gas to interact with this, either state variable or function. If it is orange, that means you need gas to interact with it. It causes a state change, but only red functions can accept ETH in it. So if you want to add something in the value field here, you can only interact with the red parts of it. So this is how Remix differentiates between the state variables functions based on if they're read, write, or payable. So only payables are defined in red. So that's it for today. I'll stop here. Next week, we will look at some more advanced concepts like contract-to-contract inheritance. We'll talk more about other constructs also. We'll also talk a little bit about optimization techniques. And then the following week, we'll get into tokens. And then the week after that, we will do a hands-on project for a use case. So I'm going to stop here for now and hope today's session was useful.
Do we have any questions? Let's just wait 1 minute for any questions if you have any. Or you can redirect those questions to Slack channel, or you can ask them directly to Ovia by reaching her out on socials. All her socials are available on the Slack channel's bio.